Okay, so this is 16.1, and we're doing integration by parts. And what you're going to see is that this is actually a technique that turns complicated integrals into something simpler. So it's a technique that makes complicated integrals into something simpler. First day we talked about integration. There was a list of basic integrals or anti-differentiation rules. So you're pretty familiar with those. You've gone through every time you've seen a definite or indefinite integral and you've said, okay, can I simplify this in some way and use one of those properties? If not, I'm going to use U substitution. And now we move to that next part. If you can't use U substitution, you're likely going to have to go this direction. So we're going to start off with a very mathy definition. We're going to talk about U and V, so just kind of bear with me for a little bit. You'll see how this plays out. But let's write this out. It says if U and V are both differentiable, then the integral U dV can be rewritten or is equal to U times V, so UV, minus the integral of V du. Okay, it doesn't make a whole lot of sense to you right now, so I'm really asking you to repeat this maybe 50 times to yourself. I can still hear my Calculus 1 teacher saying the integral of U dV equals UV minus V, the integral of V du. I can still hear it, like just a repetitive, I could hear them in my head, UV minus integral of V du. You have to have this memorized. You're not sure quite yet why, but you need to have this memorized. What this is saying is that we're going to have an integral that's pretty complicated, and we're going to be able to say from that integral we're going to determine or call something our u, and then we're going to call whatever's next to it the dv. And from there we will be able to work out and rewrite it with this right hand side. So let's just take a look at an example where you're like, I don't know what to do with that with the knowledge I have so far, and let's see how we actually use this technique. So here's my first example, and I'm going to put I put a little 1 here, but really this is one problem and I'm going to show you 2 choices. So this is the first way I'm going to write it. I'm going to say the integral of x times e to the 5x dx. We're supposed to solve and find the antiderivative. So I'm handed this, and according to everything I know, I go through and I'm like, is there a way to just add 1 to the exponent and multiply, or rather divide by that? Nope, this is a little too complicated because I have an e to the 5x multiplied by the x. Okay, u substitution then. Usually when I see something like this, what do I think with u substitution? You would make your u the 5x. So I kind of go through my head and I say, all right, if I make my u my 5x, then when I find my differential, what's the differential of 5x? It's 5. Does that do anything to get rid of this extra x term? So I kind of go through all the thought processes I've had, and I go, this actually I can't do with u substitution. So there has to be something different, and that's where we get to this integration by parts. So I need to look at this and I need to say, okay, let me come up with a way to write this. Should I call this first term, and you'll see where I'm going, so again, kind of bear with me. I could call this first term, that x, my u, and I can make this last bit called dv, and you'll see how this plays out. So I have this choice because I want to make it look like kind of this formula that I'm using. Some mathematicians said this is going to work to make this less complicated. Right now you're not really seeing why, but I can say that this first term is u and this last term maybe is dv. and we'll talk about how to deal with that. Or I can rewrite this in another way. I could have written that same integral. I could have had it as e to the 5x times x dx, right? These are the same, it's the same problem I'm asking you to solve, just rewritten in a different order. And in this case, I could say that e to the 5x is my u, and back here is my dv. So there's really two choices here on how I can proceed with this integration by parts. And this is going to come up every time, and at some point when you have enough practice, you're going to go, here's how I'm going to approach it every time I'm going to make such and such my dv. Okay, but we're not there yet. So right now, all I'm saying is that we're going to look at this. We're going to call one of them u and one of them dv, and you guys can clearly see there's two options because I have two functions here. I have an x and I have an e to the 5x. Okay, so just kind of trust for a minute. Let's try choice 1. So I'm asking you to just kind of hang with me for a second. We're going to try choice 1, which I'm going to rewrite down here. Oops, I don't know why that meant to do that in a different color. Okay, so I'm going to use this formula. I'm saying the first thing x that I see is called my u, and the last set of terms back here, e to the 5x dx, is my dv. So let's go through what we know about when we work with u. So this is us going through using that same sort of idea of u substitution. I have made u equal to x. And what do we do after we determine our u? Find the differential. So I'll go du then is 1 dx. And I could just write dx. Okay. So this is what I would do before. That's not going to quite help us. There's a little bit more to it. Now I'm saying I've determined something else to be called dv. And so let's go through off to the side. I go, well, dv I've said is going to be equal to e to the 5x dx, right? And if I want to go from dv back to a v, because my formula up here in red says I need a v, how do you go from dv back to v? The antiderivative, that's right. So what I want to do is I want to find out what v is. So I'm going to take the antiderivative, right? Okay, so I apply it to both sides. The antiderivative of dv is v, isn't it? Right? It's like I have a 1 sitting here. Okay, so I have on the left-hand side v is equal to, and then I take the antiderivative of the right-hand side. What is it? Yeah, this is actually one that we've done before. You can make this your u if you want, but actually we said it was like a kx, right? Okay, and so this becomes, someone said it already, 1/5 e to the 5x. And normally we would put, because it's an indefinite integral, we would have plus c, but we're going to come back to that because all this stuff is going to be used to go back into where we have that red bit. And so a constant plus a constant is just another constant. Okay? All right, so does everyone see that I had to make a determination of what my u is and what my dv is just to even use something that looks like my formula? So what I'm going to do is I'm going to rewrite this, and I'm going to do a lot of rewriting just for the sake of my notes. I have the original integral x times e to the 5x dx, and above it, if you are not able to change colors, you may want to indicate very boldly, again, that you're assigning this to u and then dv, so that now we can fill in this right-hand side. So I'm saying what I am given is this left side. I made some determinations. I've now worked with u and with dv to find the other additional elements like the differential or v, the antiderivative. And I'm going to rewrite this in such a way that it's u times v. You guys see where I am? This is going to be u times v. Well, what's my u? X. And so I'm going to even go off to the side here. And I'm going to say I'm going to do u times v, so I'm going to draw this arrow. I'm going to multiply these. So u times v is going to be x times 1/5 e to the 5x. Do you guys agree with that? That's my u and my v. Okay, so I've got my u times my v. What does it say I do according to this magical formula? I'm going to subtract, so that's what it says up here. I'm going to subtract, and I need an integral symbol, right? And what's it say I put in there? V times du. So you see how I'm drawing this arrow from v to du? Okay, so v then is written as 1/5 e to the 5x, and what is du? Dx. Okay, and so above this, I'm going to go in and say this is v and this is du. So if I pause for a moment, you should be able to go back and say my u v minus my integral of v du. So it's important really to repeat this, probably like 50 times today, just to get that in your head, because you have to know the order. The order is obviously going to matter. Okay, so I have taken this ugly integral I didn't know how to do anything with, my u substitution wouldn't work, and now I've written it as uv minus integral v du. Do I have an integral that's easy to work with? Can you find the antiderivative of this part I'm putting a box around? Yes, okay. So all I have to do is actually come down here, rewrite this first part, and then finish out the problem. So I'm going to rewrite this as 1/5 x e to the 5x, so just reordered it. If I want, I can move that 1/5 in front of the integral symbol and then find the antiderivative, which we've actually already done. And so I'm just doing a little bit of rewriting. So I've taken down the uv. I have 1/5 times this antiderivative. What is the antiderivative of the e to the 5x dx? Yeah, we actually just did it, didn't we? It's going to be 1/5 e to the 5x, and what do I need now? Plus c. And so the last little bit that I'm going to do is just simplify. So I'm going to have 1/5 x e to the 5x minus 1/25 e to the 5x plus c. And then if I'm considering like multiple choice options, these are things that since the beginning of the semester we've practiced on. You get down to an answer choice, like it doesn't exactly look like the answer choices, so you start thinking about ways you can simplify it. So are things kind of coming to mind for you, like factoring something out? Could you factor out a common factor of 1/5 and e to the 5x? That kind of stuff. So just be aware of those things. Like this is fine, but I want you to be aware that you still may have to simplify. Okay, so we actually solved that problem. Let's now work with, and since we're in this section, your brain's primed to know this is going to be integration by parts. Let's now work with the integral of the quantity 8x plus 10. Looks terrible. Times natural log of x dx. So it says solve or find the antiderivative. This is our problem. When I am in 16.1 homework, or I'm talking about 16.1 specifically, your brain goes, I know it's integration by parts, but let's say we're preparing for our exam or a final exam, you're not going to know, right? Your brain's going to go through all the same steps as it did before. Can I simplify this in some way to make this easier? I could try to distribute the natural log of x, but I don't know how to take the antiderivative of natural log of x. So simplifying algebraically doesn't work. Does your brain go, let's try u substitution? Maybe. That's what you should go to next. What would you think your u would be? Which one? Basically, we've been thinking about this. The quantities have been our u's. That's not going to help here because there's nothing that's going to cancel out like the natural log of x. Okay, so we've gone through those steps. Now we go, I'm going to have to use my integration by parts. Okay, so once you make that determination, and we're going to write this down for the sake of our notes, I go integration by parts says I'm going to have the integral. I'm going to come up with it as what? How was this written again? u dv equals uv minus integral v du. If you leave today and you have that down, that is wonderful. Okay, so you need to be thinking that. You're playing like a kind of a match game. So I have this memorized. I know I'm going to have to use it. I go through and I say, I have to make my integral look like a u and a dv. I have to make that determination. So you have two choices with this. I can make this first part my u and this last part my dv, just as it appears in my formula. But I just mentioned something a minute ago about dv. If I have to go from dv to a v, that means dv has to be easily integratable. Do you know how to find the antiderivative of natural log of x? Do I know how to find its derivative? Yes. Do I know its antiderivative? No, we don't. Okay. So what that tells me is that that order it's written in isn't helpful, or it is, but I'm going to have to rearrange it. So I'm going to call this quantity my dv, and I'm going to call, well, I shouldn't put the bubble over that. So actually, let me rewrite it so that it's, I want to have that dx over here. So let me rewrite it so it looks nicer for the notes. I don't want to make that junky. So I'm going to rewrite it with that natural log of x in the front times the quantity 8x plus 10 dx, and then this will be in that exact order that we want it. So we're going to make natural log of x, as I was denoting, our u, and then back here, that 8x plus 10 dx, that's going to be my dv. So that looks a little bit nicer. I don't have to jump spots. Okay, is everyone clear on why this is my dv versus the natural log of x? Could you explain to me why am I not using natural log of x to be my dv? Yeah, I don't know how to find its antiderivative. Okay, so good. Okay, I'm going to give you just a moment to do that first part. That first part says I'm going to have to find my differential of u, and I'm going to have to find v. So we're going to pause for a second. Okay, so again, u is natural log of x. Its differential is 1 over x dx. We determined dv to be the quantity 8x plus 10 dx. So I need a v according to this formula. So to go from dv to v, I need to take the antiderivative. So the antiderivative of dv is going to be v. Then I do the same thing to the right-hand side. What is v actually equal to? 4x squared plus 10x. Does everyone agree with that? You added 1 to the exponent, multiplied or divided by it, however you, multiplied by the reciprocal rather, or divided by it, however you look at it. Okay, so the next part we're going to do together. So what we are saying, and this is just for the sake of rewriting in my notes, we're saying that our integral started off as the natural log of x times the quantity 8x plus 10 dx. So it's my u dv here, my integral of u dv. And then above it, you'll see that I'm going to go ahead, for the sake of memorization, I'm going to say this has to be uv minus the integral of v du. And all I have to do is fill in the pieces below it. Okay, u times v. And you'll notice I'm drawing an arrow. What does u times v look like? Natural log of x times 4x squared plus 10x. Okay, so that's my uv minus my integral, and tell me what to write. V is 4x squared plus 10x, and then my du, good, it's 1 over x dx. Okay, so guide me through the next part. I'm going to rewrite natural log of x times the quantity 4x squared plus 10x. Do I want to simplify maybe a little bit before I find the antiderivative? So what would you do to simplify this? Yeah, I can go ahead and factor out an x is what you guys are saying, then just divide it out, right? Okay, so I can move the 1 over x to the front here, and then I'll factor out this x. Is this what you guys were telling me? So that you can see the x's will cancel, right? Factor of 1 here. Okay, so on the next line, I am just rewriting. And I'm looking for the antiderivative of the quantity 4x plus 10. Is that correct? Okay. And so I've got a bit of rewriting. What I'm going to do is move that quantity 4x squared plus 10x to the front of natural log of x so it's not confused as part of the argument of natural log. Okay, so I've rewritten that, and can you tell me about the antiderivative? So you add 1 and divide by it, so it's going to have a 2x squared plus 10x plus c, and then I've left a space. Can anyone tell me why? So notice that it says you're going to subtract the antiderivative, and the antiderivative is a quantity, right? So I need to watch. My signs will actually need to change, but not for the c, because plus or minus the constant, we don't know what the constant is. So I'm going to have a minus 2x squared, a minus 10x, and then we don't know what the constant is, so it doesn't matter about the sign. I'm going to click back because I didn't have to talk about that distribution of the negative on the last problem. So let me scroll up. Notice that last problem we have, when we found the antiderivative, it was a single term. It didn't matter. But down here, this antiderivative is actually multiple terms. And so you have to watch and be careful. You could miss this entire integration by parts problem just by a sign. Like you could have gotten down to I've used the formula, but you may have just missed this part. So is everyone clear why that negative had to distribute? Because it clearly says I'm subtracting whatever the integral is, whatever that antiderivative is, and it's multiple terms. Okay? Okay, so before we get to the next one, a few notes. I've already said them out loud. I'm going to put a little bullet point here. So u must be easily differentiable. And we're going to keep in mind that dv must be easily integratable. So keep that in mind as you go through and you say, here's a complicated integral. It's going to require this integration by parts. How do I determine what u is and how do I determine what dv is? Well, keep in mind u has to be easily differentiable. dv must be easily integratable, and that's by the fact that you're going to find the differential of u and you're going to find the antiderivative of dv. Okay, so let's move on to the next example. Okay, this time you see the word evaluate because we're going to work with a definite integral. So our definite integral is going to be from 0 to 3. Our integrand is 3 minus x all over 3 e to the x and then dx. Okay, so let's talk through some techniques that you should be thinking about. Previously, when you would see a rational expression, you would say, can I split this up with the common denominator and easily take the antiderivative? That was the first thing we did when we saw these problems. Nope, not gonna help the situation out. Okay, so you go, all right, if I do a u substitution, a lot of times our u substitution has come from the denominator. That denominator is actually what's making this complicated. So this is an integration by parts. I mean, we are in this section, but I want you to be able to think about these things. So as we move over to discuss the integration by parts, you're going to have to think about what is easily differentiable, what's easy integratable. You can always easily find the antiderivative of something involving e, can't you? Like, what's the antiderivative of e to the x? It's e to the x. What's the antiderivative of e to the 3x? 1/3 e to the 3x. Okay, so if you see something that involves an e, and you know you're going to have to use integration by parts, usually that e term is going to be your dv. Yeah, I can easily integrate e. So let's see how that plays out. So I'll put a note off to the side, and I'm going to say you can find antiderivatives easily for terms involving e. Okay, so a lot of times you're going to look at the stuff with the e when it's complicated and say, all right, that's going to be my dv. Okay, so I'm now going to rewrite this. I'm going to take that numerator, which is 3 minus x. I'm going to move it to the side so that I have 3 minus x times 1 over 3 e to the x dx. When you guys agree that's the same thing, I've just split apart that multiplication. Okay, so keeping in mind what I said about the e, this back end is the dv, and that 3 minus x is the u. Okay, so off to the side, you're going to have your u, you're going to find its differential. You've determined what dv is, you're going to find its antiderivative. So I'm going to give you a moment to test yourself on that. Okay, so you've got your u is 3 minus x. Its differential is going to be a negative dx. Our dv we've rewritten cleverly as 1/3, and I've rewritten this as e to the negative x. So when you're looking to find out what your v is, you're taking the antiderivative. So I've got v is equal to, and then what's the, what is it equal to? Yeah, the antiderivative of e to the negative x is just going to be negative e to the negative x. So I've got this 1/3 times -1 times e to the negative x. And so I can rewrite that as you just said it out loud. It's going to be -1/3 e to the negative x. Okay, and it normally has the plus the constant, but we realize at the end the constant plus a constant is another constant. Okay, so now our job is, yes?
How did you get du?
How did I get du? I just took the, do you agree with what we made u to be? It's 3 minus x. So du is the differential. It's just saying that I'm going to take the derivative with respect to x of 3 and negative x. So the derivative of 3 is 0, and then the derivative of negative x is just -1. And then we have to include the dx. Okay? Okay, so can we rewrite this? Have you already done that? All right, so if you've done that, let me catch up. Okay, so I've got u dv. Okay, and what was it again? Integral of u dv is equal to uv minus integral of v du. You got it down. The rest of you guys have it down without looking? We're going to try to repeat as much as possible so in class we do that recall, and at home you're not struggling to look back at your notes. Okay. U times v. It says fill in what u times v is. We're going to write that as the quantity 3 minus x times -1/3 e to the negative x. Right, that's u times v. Okay, minus the integral, and what do I fill in for v? Good. Negative 1/3 e to the negative x. And then it says du. What's du?
1/3 e to the negative.
So this is my v. What it goes here? A negative dx. It's going to be multiplied, right, by a negative dx. Okay. So that looks pretty ugly because I have some extra signs in there and things. So let's rewrite this a little bit cleaner. You've got a negative 1/3 times a negative 1. So it's a positive 1/3. And I'm going to move that to the front of my integral. So all I've done is I've simplified by multiplying those two numbers, negative 1/3 and a negative 1. And then I've moved now that constant. Yes, did I miss a sign? Yes. We are now working with a definite integral. So I would have caught that in about 2 seconds, so thank you. Okay, so we are now in one where we're evaluating, so it has bounds. Okay. Let's go through and find the antiderivative. What's the antiderivative of e to the negative x? It's a negative 1 or negative e to the negative x, right? Do I have a plus c here? No. Why? Definite. Okay. All right, so fundamental theorem of calculus. I'm actually going to use these bounds on this entire thing. You evaluate it first where? At 3, and then you subtract what you get when you evaluate it at 0. Okay. Okay, so any questions about plugging in first the 3, then the 0, subtracting, breaking it down, type it into the calculator, round it to maybe, let's go out to 4 decimal places. What do we get? Okay, I think that's right. 0.6833. Does it continue? Okay, yeah, so 4 decimal places. Okay, so it's just plugging in, subtracting, making sure that every little step along the way that you're just being very careful. So the only real part of this that was calculus is working through this integration by parts, is setting it up. After you get to this point, it's just plugging in and making sure you do the basic arithmetic. So just be very careful, I caution you. Okay, let's try this one. It's going to be an indefinite integral. X squared times e to the 3x dx. You know you're in the section on integration by parts. You're going to have to use it, but I still want you to go through the ideas of, can I simplify this? Could you substitution work? And then your last resort is going to be integration by parts. Okay, so I want you to work on this, and we'll regroup. You may have figured it out. Okay, let's regroup. You made this last part dv and this first part u. So off to the side you said, I want u, du, I've got dv, and I want v. Okay, u was x squared. Du is 2x dx. Your dv is e to the 3x dx. So when you took the antiderivative, you found that to be 1/3 e to the 3x. Okay. You rewrote this. You said this is the integral of u dv is equal to uv, which is x squared, times 1/3 e to the 3x, uv, minus the integral of v, which is 1/3 e to the 3x, du, 2x dx. Okay, so I think that looks ugly, so I'm going to rewrite it. And this also will help me. So all I'm doing is moving that 1/3 to the front of the x squared. I am going to multiply the 2 times the 1/3 I'm going to move that outside of the integral. So I have minus 2/3 times the integral of e to the 3x times x dx. Are we all at the same spot? And what we've been doing is we've been saying, let's take this antiderivative. Could you take that antiderivative as it sits? You're searching through your head, you're like, if I multiply these things, is there something that makes it simpler to just use one of those rules? No. If I make something u, which usually is like a 3x, I take du and something should cancel out. Is that going to happen? No. So what's my next tool? What we're doing now, aren't we? Integration by parts. So this is one where I'm going to have to complete this with integration by parts again. So now I'm going to apply integration by parts. And this time I'm saying again, so I have to take this complicated integral and make it into something simpler. So it's going to be performed twice in this case. So this is a good time for us to discuss again what's going to be your u. U will be my x. Okay, so my du is dx. Okay. My dv then is this e to the 3x dx. All right, I'm going back to this little part here. Got a couple eyebrows, so I have my dv and my u. Okay, what's my v? 1/3 e to the 3x. Okay. As I move through this, I'm going to keep note that that first term is going to carry down that I just drew a circle on. So this is all going to be involved here in a moment. And I'm going to have to subtract 2/3 times whatever I get next. Because I'm about to do the uv minus integral v du again. So I'm carrying down that first part that we did a moment ago. I'm going to have minus 2/3 times whatever I get here. And so can you guys tell me what I start writing? uv. Okay, so it's going to be x times 1/3 e to the 3x. So I've got my uv. Excellent. Minus the integral of 1/3 e to the 3x. That's my v. du is dx. Okay, can I do that? Now it's something mathematically beautiful I can work with. So I'm rewriting a lot of stuff. I'm reordering some multiplication. The antiderivative of that integral I have left, we've been doing that one a whole bunch. What's it going to be? This is going to be 1/3 times another 1/3. 1/9 e to the 3x plus my constant. And so I would have to now distribute my negative 2/3. And I'm just doing a whole lot of rewriting here. So when I carry down, I've got 1/3 x squared e to the 3x minus 2/9 x e to the 3x plus 2/27 times e to the 3x. And then I've got the negative 2/3 that says it multiplies to the constant. It's just a constant, right? So it's going to be just plus d. And then we think about, at the end of this, we go, there's a whole lot of stuff I could do. I could factor out common factors, but this looks great. And if you came up with this on your own, or if you understood that, you have almost mastered this, aside from now you have to be tested over it, right, in some fashion. That one, if you got Okay, so we're just going to recap everything that we've done. You're going to put in a little note on your sheet of paper, integration by parts. Okay, this is kind of just to wrap it up. So we're not going to look at our notes or anything. We're going to see if we have this memorized. What does integration by parts do for us again? First thing we wrote in our notes today. Makes a complex integral simple. Okay, I have an integral. It looks like the integral of u dv. We are filling in together based on participation. What do I put down next to it? uv minus integral v du. Okay, we all know that. Okay, the next couple things that we do is we're going to actually determine what we use substitution or not. So put a little note that says by parts versus substitution. I'm going to write down an integral, and we're not going to solve it, but you're going to tell me what should we use. I've got the integral of x squared over x cubed plus 5 dx. How would I seek to work this? By parts or by substitution? Substitution? How do we know that? So I'm hearing your u would be the x cubed plus 5. Your du turns out to be 3x squared, which will end up canceling with the x squared. Okay, good. So by substitution. Does everyone know why? Okay. So it's by substitution. All right, the next one. X squared times the quantity x plus 4 raised to the 1/2 dx. So let's think through this. I can't multiply under a radical. That's really what that is, right? It's the square root. So I can't simplify. Let's see. If I think about u substitution, what do you propose our u is? X plus 4. What happens when I take du? It's just dx. Is that going to help me? Okay. So what do we think? Okay. By integration by parts. And I'm really saying solve by integration by parts. Any idea on what your integration by parts, what you would make your u and your dv? This would actually be my dv back here. But that's for what we did earlier. So just kind of think about it. Right now we're trying to determine what's the difference between using these, or which method rather. Okay, let's do 2 more of these. X cubed e to the x raised to the 4th. Substitution or integration by parts? It is substitution. How do you know that? Yeah, you should think about this is your u. When I find du, it's going to end up canceling with that x cubed, right? I'll be able to simplify it. Good. Okay, last one, and then you're going to hand this in, and you're done. The integral of 1 minus x squared, the quantity, times e raised to the 2x dx. Substitution or integration by parts? Tricky. Let's come to a consensus. What do we think? How about you pick one, and then you can turn it in, and I'll tell you what it is. Or do we want to go through it real quick because it's time? If I use u substitution, what's your u? Usually you think about this. Is that going to do anything to cancel out? It's integration by parts. Okay, turn that in. Have a great rest of the day. We will pick back up on an example next time. And